Hello everyone, I'm Akash, founder and director of Prime Minister of Mathematics, Amravati. In today's video, we will solve a multiple choice question on complex analysis from Maharashtra Set 202 for exam. Question is, if all roots of the polynomial equation 1 plus z plus z square up to so on z to the power 10 are in the disk b of 0 comma r, that is disk with center 0 and radius r, then the value of this integral along the boundary of this disk, that is mod z equals to r, is what? And the options are option A 0, option B 10, option C 10 pi I, and option D is 20 pi I. So let's begin the solution. To solve this question, we will use a famous result from complex analysis, and that result is argument theorem. Okay, we will use this famous result from complex analysis. This theorem states that if f of z is analytic inside and on the simple closed curve C, except at finite number of poles inside C, then the value of the integral 1 upon 2 pi I integral along a curve C f dash of z upon f of z dz is equals to n minus p. Okay, where n is equals to number of zeros of f of z inside C counting multiplicities. Okay, and p is equals to the number of poles of f of z inside C counting multiplicities. Okay, so this is the theorem, and we will use this theorem to solve this question. So let us see. Here in our case, we can see that the form of this integral is same as the form of integral in this theorem. This is f of z and this is f dash of z. To see this, derivative of 1 is 0 and derivative of z is 1. Derivative of z square is 2z. Derivative of z cube is 3z square, and so on. Derivative of z to the power 10 is 10z raised to power 9. So this is f of z and this is f dash of z. Now let us check that we have the required condition or not. Clearly, f of z is polynomial function, and we know that the polynomial functions is analytic in a whole complex plane. So it must be analytic inside and on the boundary of this disk. So f of z is analytic inside and on the simple closed curve C. So this condition is satisfied. Okay, and except at finite number of poles inside C. F of z is a polynomial function. It has no poles. We know that. So this condition is also satisfied because it has no poles. So it has only finite number of poles. That means 0. So 0 number of poles. So what is given? Given that p is 0. That is number of poles of f of z inside the boundary of this disk is 0. So value of p is already given, which is 0. Now we know that f of z is a polynomial function, so it has at most 10 zeros. That is, it has at most 10 roots, and it is already given that all roots of this polynomial is inside this disk, that is inside the boundary of this disk, that is inside mod z equals to r. It is already given, and it has, we know that it has 10 roots at most. So all these 10 roots is inside this boundary of this list. It is given. So it is given that the value of n is 10. So now we can easily solve this question. So according to this theorem, 1 upon 2 pi I integral along the chord C, chord is here mod z equals to R. And clearly this chord is a simple closed chord because it is a boundary of this disk. That so that it is a circle with center 0 and radius R. And we know that the circle with center 0 and radius R is a simple closed chord. Okay. So according to this theorem, the value of this integral f dash of z is 1 plus 2z plus 3z square up to so on 10z to the power 9 upon 1 plus z plus up to so on z raised to power 10 dz is n minus p. N is 10 and p is 0. So if I multiply this whole equation by 2 pi I, then we get multiplying by 2 pi I, we get 20 pi I. So the value of this integral is 20 pi I. So the correct option is option D only. If you found this video interesting and helpful, then please like and share this video and subscribe to our YouTube channel. This will motivate us to provide you more valuable and interesting content on mathematics. Thank you for watching.